Hello, everyone, and welcome to our webinar. This webinar is actually part two of our webinars of Swiss type part programming. And again, this will be given by our expert in Swiss type programming, Marina Vilkina. And of course, this is being recorded, and the recording will be available for everybody later on. Again, if you have any questions, we'll try to get to them at the end of the webinar. Again, if we do not have a chance to get to the to answer them, Marina will get all the questions, and she'll also be able to email you all the answers as well. So, Marina, I will make you the presenter, and you can go ahead and show your screen, unmute yourself, and start.
Thank you, Sydney. Just double check if you can see my screen.
Yes, I can.
Very good. Thank you. Hello and welcome to the webinar. This is the second session, and today I will finish the part that I started during the last session. And before I will start, I would like to thank you for the feedback, for your questions and valuable notes that I get after the first webinar, because I'm going to start from a cutoff and part transfer process. I would like to make some changes in my tool table and to add comment about one issue that comes after the last webinar. The issue was about cutoff tool mounting. I will open my tool table, which were created during the previous session, and this is my cutoff tool here. As you remember, I added a right-handed tool and then I flipped it because I wanted to show how the tool position can affect on machining length parameter, but I didn't mention that in a real life, programmers are trying to avoid to flip a right-hand tool on a Swiss type machines. This position can be used, but for left-handed tool. Why? Because of rotation direction. You will have to apply counterclockwise or M4 command for direction of the spindle rotation, but other tools in this section, OD turning tools, they will need M3 or clockwise rotation direction. That means that you will have to stop the rotation, will have to stop your spindle to perform the cutoff operation and then to turn it on and to change the direction of rotation for each part. But as it's known for the Swiss type machines, it's a cycle. You will apply this program again and again. It may be like 1,000 parts from one program, and this stop can affect on a time, and it will be longer. So I will change my tool to the left to not change the direction of the rotation of the main spindle, and I will apply some mounting here again. I will flip it again and move a little bit in Y and Z direction. I will apply it like this. So now it is left-handed, and I still have my flipped position for the machine to perform a longer machining length. As I opened a tool table, I would like to add other tools which I'm going to use today for the operations on a back spindle. So I would like to add some tools here to this tool table. This is a tool block which we can call a back tool post, and it can move only in Y direction. It's Y direction for the back spindle, for the second channel. As you can see, there is no tool holders here as for this tool holder. we don't use it in STL model of the machine because you can use all the stations both as for milling and as for turning operations. So they are all driving, but if it will be driving or not depends on the tool holders. And of course, tool holders are related and depends on the type of the tool you are going to use here and type of the operations. And my first tool here will be the tool for OD turning on a back spindle. I will perform facing in the OD turning operation. It will be my two first operations after the cutoff and part transfer. And before I will add some tools here, let me show you a couple of pictures from citizen machines from my practice. Here you can see a simple ID turning tool. It is here, which is used for OD turning operations. So normally you will not use any additional tool holder here. You may use because of the shank diameter, but it is like a common, you just put the tool to the tool holder. From other side, you can use a special tool holder with cartridge. It is like an assembly. It consists from several parts. It's a special tool holder. And you can perform both types of the holders inside SolidCAM. For the special tool holder, you will need to use SolidCAM STL tool holders database. But in this project, I'm going to use a simple default holder and simple default tool. So I will just click on a turning tools. We'll choose tool for internal turning, ID tool. Then I will choose the correct turret. Here it's T30 tools. Then as you can see, I need to flip my tool or change the tool direction. First of all, I would like to apply a 55 degrees insert. Then I will apply it as a left-handed tool. And then I should mounting it inside the hole here, tool position. First of all, I will choose the length of the tool. I would like it to be shorter. And then I will apply this value. So this will be the distance between the tool tip till the center. So I will apply it here like 19, and here I would like to apply something like 60. So this is the position for the OD turning tool. And of course I will change the tool number here. The next tool will be a milling tool. So I will go to milling tools, choose my end mill, and I would like to position it here to have a space and to show some interesting features that we have for milling on a back spindle. I will change the number to 33. I will leave the diameter as a 6, and here I would like to have 35 millimeters from holder, but I don't have holder here now. And after I enter it, this number, there is no changes on the mounting window. So to do this, I should apply holder first. So I go to holders, to my STL database, and I will choose a holder here. And now you can see that these figures were applied to the holders. I can change it again just to show how it works. So this is one of the questions that I get. I got several about the outside tool holder length and edge length. So there depends. You should enter here some numbers if you don't apply an STL holder or whatever, not STL, just maybe simple holders from the default database. If you don't apply holder, you have to change these numbers to get some result as I did it here. So this will be my tool for the milling operations. And the next thing I would like to show here in the tool table is a little trick about how to not put such a complex assembly of the tool and just apply the results which we already get. So the next tool will be a drilling tool, and to apply this I will just copy the current tool and I will apply the nice command that we have here. It is called change tool type. And here I will choose my drilling tool, and I would like to put it to the lower row of the tools. I will put it to 36 position, and I will change my tool number, and then I should change my tool diameter. For this purpose, I can just click on a 3D model here. So I just click on the diameter field and click on my diameter, and system will automatically calculate the diameter of the drill. Okay, I will apply my 35 OHL lens here, and then here I have the drill, or the complex one, with 2 diameters. So I will copy this drill and create one more drill here. I will put it to the next position, like 38 here. And all I need to do, because I already have a good OHL parameter, is just to change my tool diameter again. That's it. Now, no, I will change my tool number again. So I will just save it. And okay, so its tool table is filled. So I set up all the tools on the machine. And now we are ready to perform a cutoff and transfer process. For the multi-channel machines and Swiss type machines, part transfer from one side is a complex procedure, but from other side it is constant routine with a couple of variables. Before I will start to do something inside the software, I would like to consider this process for the particular machine. For this operation, I will open the code for the cutoff and part transfer for Citizen machine. It may change a little bit from machine to machine, but the main idea will be unique for all the machines. So here you can see 2 columns. The left one is for the first channel and the right one is for the second channel. And as you can see, I divided code a little bit visually, so I can find several units here. And these units are divided with code which is called the weight mark. Citizen machines has 2 types of weight marks. The first one is common for all multi-channel machines with Mitsubishi CNC. It is looking like exclamation sign and L, and then you will have the number of the weight mark. As you can see, they are the same for the both channels. And the second type is a very specific, used for the Citizen machines. It's G600 codes. So there are several. 600, 610, 620, there are several. For this webinar, I will use 3 of them, and I will try to explain what that means. They are not called like weighting codes. In the programming manual, you will find it like machining patterns. This is how they are called there. So let me quickly explain you what's inside of this program. So the first block, and we will perform it inside the software. What we're going to do, we should choose the tool, which will be the cutoff tool. Then we should pull out the part from the main spindle. This is the will be the distance for the cutoff. This is the position of the cutoff tool. It's a safety position. I will remind you that Citizen, I reviewed the model which is called L32. So 32 is the maximum part diameter for this machine, and X40 will be like always safety position. But we will make it like variable, so customer can choose it and to change it inside the software. So all these three parameters, like variables, they may vary, but they always should be where you can see it inside the code. The next step here is the cutoff speed. So it's a rotation speed for the cutoff. This is the speed for the main spindle and the direction of rotation. If I would choose the right-handed flip tool, I should put here M4, but this is and in our project we will use M3, and this is the rotation for the back spindle. This is the synchronization code, the common code for all Mitsubishi controllers. That means that the second spindle will follow the main spindle in terms of spindle speed. It is not about the linear movement, the movement, it's only about speed. So they will rotate in the same direction with the same speed, that's all. This is a special command. It is called interference checkoff. So it lets back spindle to be to go and to clamp the part, because Citizen is a very smart machine and it checks where its back spindle is, or what's the part length, and if they can interference, and the machine prevents gouges. So I just turn off the interference because I have to clamp my part, and so the part will be inside the back spindle. So I should turn it off. Then I will have a very special code here, and I would like to show you the short description of this code. Inside the manual, it is called Pickoff. S and G60050. It is not a simple wait mark. Each machining pattern, it's like a macro inside the code. So according to this macro, machine knows what to do. Machine knows what it can do and what it cannot, and what accesses it can use and where to move. According to these lines here, you will get some additional codes inside here. So you will you should know what is inside of this code, because machine can even move without any data here about movement. It can move and it will be moves because this movement is inside of this macro. It's like a macro for the probing maybe, but this is a special macro for the machine. And there are description, of course. As we can see here, this is machining pattern enables the back spindle to pick off the workpiece and supports the center of the workpiece. And here we have short description, graphical, about what should happen on the second spindle. So here you can see two steps for the back spindle. The first one, back spindle comes to the stock. This is the stock, and we will have, in this example, 1 millimeter before the face, the distance between the noise of the back spindle and noise of the part, and then it should move further. Of course, it should unclamp, moves in some feet, so it's like G1 movement, and then clamps again. And after that, we will have our cutoff operation. I will remind you that movement of the back spindle should be programmed on a second channel, but cutoff and movement of the tool, OD tool, is always programmed on the first channel. So you should divide these operations on several channels. I will go back to my code. So this is the first block. The second block will be about the clamping part. So here we have several codes. Again, the interference off for the back spindle. We will unclamp the back spindle. Then we will turn on the air through spindle. Then back spindle will go 5 millimeter before the part face, and we will turn off a special command. It is command called wait until spindle synchronization is complete. So machine needs time to synchronize the spindle speed, and this code needed to check if the second spindle reached the speed of the first spindle. It's like a safety code, because some machines which do not have this code, where they're using like a additional dwell here. The next step is the movement of the back spindle, and this is the clamping position. And I would like to pay your attention. This clamping position is the position according the part face. That means 9 millimeters from part face. Then we will have some dwell and turn on the air, and then clamp the spindle and dwell again. After that, we will have some internal waiting code and go to the first channel. This is the cutoff operation itself. And after that, we will have some part change process on the main spindle. Part is on the second spindle, and this is the code about the cutting process on the back spindle. So this is T31. It's like facing and turning operation. If you had a deal previously with multi-channel machines and with Swiss type machines, you may ask me why I lose two very important codes here, because you will not you will not find here the code for the axis synchronization and about movement of the back spindle with part to its reference position out from the main spindle. Yes, because these codes will be inside these machining patterns. So I can show you the description. In here for G650, you will find that this code, without any additional description, means for the machine Z1, Z2 superimposition process. That means after I will clamp the back spindle on the part, machine knows that whatever movement I will program for the Z-axis in the first channel, the back spindle will move accordingly. So this is very smart, very nice function. I should not care about this. And this code after part transfer for the machine means that spindle should go out from the main spindle with part to its reference position. So I should not add any codes here. Everything will be automatically, but it is better for the customer to know about this, but it's because it's a little bit scary when you don't have G0 movement, but your back spindle will go with the part somewhere and you didn't program this. Okay, so this is several blocks which will be performed inside the software. And now I would like to show how I'll do this. I'll do this with a special type of operations, which is called machine control operation. So as you can see, we have milling operations, turning operation, and machine control operation. What that means? It's a special type of operations to control, to manage with the parts of the machine, with machine devices. What I can do here, I will just show you what can be done shortly inside these operations. First of all, you may use machine preview window. I would say you must use it. And what we can see here, the last operation, which were the last during the previous webinar, was the milling operation of this wrapped pocket. And now I can see that I have my gang in this position. So I can see that the milling tool was retracted a little bit above the part, but little bit, and the p-axis is still in its angled position here. So before the part transfer and cutoff, I would like, for example, to move this gang to its home reference in X direction, Y direction, and to retract the B axis to its 0 position. I would like to clean this space to see what will going on and to prevent some gouges during the part movement, because as you remember, our plan, we would like to move the part of the part out of the spindle to perform the cutoff process. So I would like to make it safety. What I can do here, so I can choose, for example, my turret, and here I have 3 turrets according the machine ID file. It's a turret with OD tools, turret with radial milling tools, and turret with B-axis. So I can choose any of this turret, because if I will input the X home position code, they will move all together. So it's not matter what I will choose here. For example, it will be OD tools. And then I have a list of the commands available for this device. And I will choose movement and will put, for example, X to its reference position. And I can see it here. Next step, I would like to apply Y to the reference, and then I would like to put my B-axis to its reference position. For this purpose, I would choose tools on a B-axis, and here in a movement, I can see that I have B-axis, and I will put it to the 0 position. There are different commands for different devices. I can even click on the main spindle and I can see a list of operations here. For example, I would like to turn on coolant or, for example, clamp, unclamp, whatever. I would like to even move my, I have a movement here, I have a movement of the part. Okay, so this is MCO operation, but as I said at the very beginning, the cutoff and transfer is a routine. It's a process that you will have every time you would like to perform the cutoff and transfer on this particular machine. So it is it's a routine, and we have just several variables here, several values that can be changed. So we, for this purpose, to not add all the steps every time for each new project, we are using what we call MCO cycles. So I can add whatever operations I need and to save it as a cycle. And as we have a deal with a machine with a certain cycle, we have the cycles for each machine inside the machine ID file. So the first step here will be a retracting of the B-axis, what I tried to perform here, but I have it as a cycle. I will choose it here, B-axis reference cycle, and after this, I will get the B-axis back. And now I can and there is no parameters here, no description, because it just will retract my gang and B-axis to its safety position. But I can see what's going on during the machine simulation. They are completely visible for the machine simulation. If there are movement or tool changes, of course, not spindle speed. So the next operation will be about the cutoff process itself. So my first operation, changing tool, position tool, and position the stock. And I will just calculate the cycle and add a new cycle with a simple button like save and copy. And here I have the first cycle, which is called Z1 positioning for cutoff. What about this message? This message is about the submachine, which will be used as a default for machine control operation. Submachine defines the channel number, and this submachine is described inside the machine ID file as the submachine which should be outputted in the first channel. For example, the next MCO cycle will have some different submachine, and I should click yes again to put the cycle to the second channel. So I will always, it is recommended for machine cycle to use always yes. So what we have here, as I said, we don't have all this long list of what to do. We have just a list of the parameters that can be changed here. The first one is the selecting of cutoff tool. And here it is. I got my tool table and I can choose the tool which will be cut off. Next step is I should enter the spin of the cutoff. If you remember, during the previous webinar, I already entered this number for the machine parameters, and now I will choose the same number. Next two parameters are about this code, this one. It's a synchronization type. It's a little bit complex. It has different values here, but you can apply different types of the synchronization. Inside the Mitsubishi CNC, you can apply both synchronization of speed and synchronization of phase. It's like a C-axis synchronization on both spindles. So this is the question. If you would like to apply phase synchronization, like C-axis on the main spindle will be the same as C-axis on the back spindle. And if it is needed, you can also apply a phase shift. So, for example, the back spindle C-axis will be shifted according to the main spindle axis. So there is a nice description for all Mitsubishi programming manuals. What we interesting here is the position for cutoff and the position for x-axis. What we can say about the position for cutoff? Here we have a special, I will just right click here and I will get the pick point menu. And what I'm going to do, I just pick the position which will be used for cutoff. So this is the position, and also I would like to add 1 more millimeter here because I would like to perform the facing operation on the back spindle. So I will choose 46 here, and to check this I will apply machine preview window again. I will choose the front view and I will check their position here. So this is the position of cutoff. It's 40 millimeters for the X as a diameter. Here we should input the radial values. So 20 means 40 during the output, and the position of the cutoff. So very simple, and you can easily check this if it's correct or not. This value will be outputted to the code. So I will calculate it again. And the next step, which I should add, but I will not have it inside the description, it just seems like I can go here and to add the operations here. So I will just click again on the new operation, and I will choose the positions for the clamping, for catching the part. Yes. And here I have two nice features. The first one is the preposition. I will choose this one. This is a preposition for the back spindle. So it's like a safety position, 2 millimeters before the part face. And then what I have here, it is not a figure, it's a setup location. And the system knows about the location of the clamping position because of the setup settings which I added during the previous webinar. This is why it is very important to fill the setup window before you will start to add parameters here in a country. So setup location, that's all. Of course, you can pick the point, you can enter the values, but it is recommended to fill the setup window for the back spindle. And after that, you can just use a setup location here. And this is if you would like to use air through spindle and the clamping feet. That's all. We will calculate it again. And as I promised, the next step, which is not visible inside the code, but should be done, it's Z-axis synchronization. So it's superimposition mode, this one, because after the back spindle clamps on the part, they will move together, they will be relative. So I will add a new MCO, and we'll just add a Z1, Z2 synchronization process. It is important for the machine simulation process. So SolidCAM should know that synchronization were turned on. Okay, now I can perform my cutoff operation, and I will edit as all turning operations. I will choose cutoff, and I will use Mach 1 position. I will just choose a back face of the part. Here I will modify a little bit my geometry till the end. So it's a common cutoff operation. I will choose the tool which was chosen during the preposition MCO. Yes, and now what I should add is the allowance 1 millimeter, which I added during the Z2 positioning for catch MCO. And the next step is very important. It's approach and retract point. I will go back to my code here. And as we can see, it is started from X40. As I said, it's completely safety position for this machine, and I will use it, but it can be changed. But and the next position, as you can see after the cutoff, will be X minus position. That means that the tool will be left at the lower point during the cutoff. It will not retract back to X40. This is the end position for the cutoff tool, and cutoff tool will be left there, and the new program will be loaded, and the new program on the first channel. The next part will be starts from this position. It's a very important thing, and this is how Swiss type machines are differ from the mill-turn machines and all other machines with the turning facilities. Okay, so here I would like to add the type of the approach only X. I will input 40 here, and here I will just choose none, and we'll calculate this. This is what we have. The safety distance, and my tool will be left in this point. Okay, that's all. Now I can turn off the synchronization of the axis. I will add machine control operation again. I will choose turn off synchronization mode. Nice. And what I should do now, one more invisible operation here. So on the first channel, I should put like a bar change mode, but before this bar change mode, I should retract the back spindle with the part in the Z direction. And there is no code, special code here, but I know it is inside the waiting code, and I will add this code as an MCO cycle for the machine simulation. So I will copy this, and I will choose Z2 part movement after cutoff. I should not add any, so I just put it to home reference position. That's all. Nothing, no values, no variables here. And the last one will be a bar change on the main spindle. This is called program and with bar change. Nothing special. Most of the values were entered during these two critical MCO cycles. Other one are default, always in EQ for this machine. Nothing changed. Now I'm ready to perform operations on the back spindle, and the first one will be facing, then turning, and then I will show how we can cut different approaches to cut this simple hexagon on the face of the part. I will go to turning operations, and I will perform a face operation here. And now I should choose Mark II position. So now I will use the coordinate system on the back face of the part. This is coordinate system for the back spindle. And it is important if you choose this position in a setup window too. If you left the Mark 1 for the back spindle inside the setup window, you will have a message here that it's not fits. So I will go here, choose the face of the part. I should check my chain. It is okay. And now I will modify my geometry a little bit, as always. Okay, I should choose my tool. I remind you that it will be tool for internal turning. It's tool number 31. This is it, the tool that will be used for the turning operation. Okay. The next step is levels, technology. I will leave it with one cut as a finish. And here our links page. I will leave just from right safety corner, and I will leave none here because I will use the tool for the second operation, turning operation 2. I don't want to extra retract movements here. Okay, I will calculate it. So this is a simple turning operation, but with tool for internal turning. That's all. Now I will apply the same tool for the turning, OD turning operation. I will just copy that, and I will turn on, I will rename it, and I will change the geometry. I will choose the first surface and the last one. Okay, we'll change the direction, apply that. Sorry. And I will leave the same tool here. We'll leave levels, and for the technology page, I will apply a rough operation type. I will apply the long external cycle here, and I will leave some low ones on the faces. And I think that's all. And in the link page, I will put optimal from previous link, and for the retracting, I will apply only Z, and I would like to apply a large value like 50 millimeters. And this is my turning cycle. Now we can check how it will look like on the machine before I will go to milling operation. Okay, what we have here, facing and turning. And because of these kinematics, I applied a long retract. If I had just 2 millimeters retract, I will have problems when my part with back spindle will goes to other tools here. I would like to apply a milling tool because it may happen a gouge. Of course, the Citizen machine, as I said, it's a very smart machine, and there are special interference mode to check the part length on the back spindle and the length of the tool, and it will stop, it will not gouges, and you will have a message, but you will have to launch the machine again from the start. So because of this, I prefer to have a long retracted G0 retract before I will go to this tool. So retracts and links are important in Swiss type machine, and they depends also on the type of the tool block. Okay, next step is the hexagon. Here I will choose it like a milling profile. I have to change the mark position to the second, and I will just choose a very simple geometry. I can choose a smart face here because I have some intersections. Okay, I have my chain, and now I will choose my tool. It will be 6 millimeter tool. The levels, as always, this is my depths, it's okay. Checking the position of the tool. I will leave it as it is, and in the links I will apply tangential and normal. And I will stop on the motion control page because if you don't have if you don't want to apply 4-axis, you can do not apply this because the tool holder, the tool block, has y-axis, but you should remember that this is y-axis is very limited, and you will go out from the limit during the cutoff, and it is common for such type of blocks to not apply y-axis and to apply 4-axis with the cutting with c-axis. Let's check how it will looks like. I will apply it like a polar and 4-axis. Calculate it, and to check it on the machine simulation, how it will looks like. This is what we have for this tool. I will just turn on simulation. So tool will not move, we will have only C and X movement performed with the back spindle. But as you can see, this tool block is very interesting. It's not so common. And why we can't apply the cutting from the other side? and to perform the cutting with X minus. We can do this, and I will show how we can do this for this operation and to not build the new operation. For this purpose, we have a separate type of combination. So here you can see that for milling, the special combination, the submachine, were applied CX plus. But if I will change submachine to CX minus, and I will recalculate the operation. I will go back to simulation. And here I will find my part from other side of the tool. It will be like X minus output. And on this moment, I will finish with adding cutting operations because, of course, I have a drilling here, but it's a simple operation. I will skip it. Now we are entering to the part about the channel synchronization and adding a second part to the system. So what will be the end of the process on a Swiss type machine? We should get rid of the part in the back spindle. It is ready. And we should unclamp the spindle and put this part to the device which is called part catcher. And after that, back spindle will be free to go back to the part transfer process and to get the new part from the main spindle. The part transfer, the part ejection process, it should be the end of each CAM tree of the Swiss type process on the machine and inside the CAM tree of the project. So I will just a couple words about the ejection process. So here I have like a sketch of what should happen on the machine. Here you can see the back spindle. It took the part from the main spindle, then it goes to the device which is called part catcher, moves towards it on a certain distance. Distance is related with the part length. Then spindle should unclamp. There is a special device which is called pusher. Here inside it pushes part out of the back spindle and part goes to the part catcher, and then there is a system helping the part go out of the machine zone. So this what should happen. The next thing I would like to mention for this machine, that for this machine it can happen with just one M code. So M34 is a series of operation for product separation. All this process will be inside of one code, and there is a description of this code. It may be applied on the machine, different codes here. So we can apply both just one code and a sequence of codes for the part ejection. Inside SolidCAM, we will add MCO cycle again, which is called part ejection. And here we have not a lot of parameters. The main parameter is about the position of dropping the part. I can move the scroll. This is the part catcher. And for example, I will apply it as 67, for example. I will enter this value. This is for machine simulation, and it also can be used to output if machine needs this certain value for the axis also. We'll calculate it. And now I can go to my synchronization table to get the result that you saw here in the code. We will need to check our weighting marks and machine patterns. So I will go to setup and will choose channel synchronization command. And I will get my synchronization table. I don't want to go very in very detail about the description of the interface because we have a very nice description inside help. But I will say that these buttons, especially this, will helps to put the weighting marks. Here we have a list of operations on the main spindle, list of operations on the back spindle, and a lot of weighting marks. My main buttons, which I always use, is delete all. And here you can see operation crash view. This window will help you to understand if there are problems with operation and you will need to change something. And the next button I always use is synchronize all operations, like automatically synchronization. I will get rid of additional weighting marks. What should be done next? Usually on the machine, or when you have your first project, you don't know if tool mounting on the machine were okay, if tools setup table were okay on the machine. If you will not have problems if the part will have its dimensions as you have it on a drawing. So we have the first run of the program, and during the first run usually it is recommended to not launch the machine, the both channels simultaneously. It is launched on a first channel, second channel step by step. Then if part is okay, tool offsets are okay, everything is okay, then we can make a synchronization. So what I'm going to show today is how to create both tables from one table. Okay, my first machine run will be step by step. The first part on the main spindle, then the second part on the back spindle. What I should check here, I have a description of the process, and I can see that I should have a weighting mark before back spindle will goes towards the main spindle, and I should have it here. This is the weighting mark, and this weighting mark should be like G650 macros, and I can apply it here. So here we can apply an access buttons, machine buttons. By the way, the free button which I using here is G600. The next is my synchronization synchronization process, which is not exist inside the real code. So I will delete this weighting mark, and I should put G650 here too, because I have it inside the code. And here I can apply a simple G600, and I will get rid of this weighting mark too. So this what I would like to apply first time. I will save this and check on the machine if it's okay. And then I will apply synchronization. Okay. The machine is ready. I'm trying to not move it during the simulation. Just click on the machine. So my back spindle is not moving. I have movement only on the main spindle here, as it was described inside the synchronization table. Some milling operations, B-axis, turning again, milling again, drilling, and the last wrapped element. This is cutoff, and then turning operation and some milling. It's like step by step. During this process, everything is checking on the machine, part is checking, the positions for the ejection, everything is okay. Now we can launch both channels simultaneously. I will go to channel synchronization table again. And what's the logical issue of this process? You can perform channel synchronization if you have two parts. One part is in the main spindle, it's a bar, and the second part in the back spindle, it's the part which is left after the cutoff. So it means for the table and for the machine that it has two parts simultaneously in each spindle. And we have a special button here, which is called Add a New Workpiece. That means that I should choose the operation, and when this operation will be launched, on the main spindle will be loaded a new part. So I will launch it with the Add a New Workpiece. And now I would like to change a little bit my positions of my waiting marks. I would like the face operation on the back spindle will be simultaneously with face operation on the main spindle. So I will get rid of this synchronization and I will synchronize these two operations. I can also, for example, if I wish, add the waiting marks whatever I want. For example, I would like to have my turning operations together, started, ended, whatever. But on a real machine, if you have an example, your example of code is like a guide. It's like a manual where you should put your waiting marks. For this particular machine, that's all. So I will show the more complex things, more advanced on during the next webinar, but for this simple sequence, it is enough. So I will start these three operations with part ejection together with all operations on the main spindle, then the part transfer will be performed. That's all. All is needed to be checked is the access patterns. If I will leave G600 here, machine will not run because citizen needs to permission. I need to allow the machine to move simultaneously in both channels. For this purpose, there is a special code, special pattern is 630. It should be put here, but for part transfer, I still need my G650. I will delete this synchronization waiting mark again, and here is G600. So this what will happen on the machine. That's all, very simple. I will save that, and now I will go to my simulation again. Okay, now you can see that my back spindle still has a part inside, and my main spindle has the part too, and it's ready to be run. I will try to show you both spindles here, and I will launch the simulation. So facing operations on both spindles, they are independent. There will be operations on the main and back spindle that should weight each other, but I will show it during the next webinar. It's more complex, complex processes, but they are available on the machine. So I will show it. But this is common, very common synchronization process, and not so much clicks to achieve it. That's all. Cycle is finished, and I would like to show you the code. What I have here, the first channel, second channel, and my main weighting marks as a access buttons. So here I have at the very beginning the operations on the main spindle together with operations on the back spindle, and they will be run independently. And on the machine they are independent. This is some milling, and this is how the first MCO cycle. I call my tool for the cutoff. This is the part position, tool position, synchronization speed, command to synchronization. Then I have operations movement of the back spindle, and here you can see the additional weighting mark. So while machine will run till this weighting mark, it will wait for the running till this mark. So because of this mark, I have some code before this mark. This code will be run on the machine before the code after this waiting mark on the first channel. So machine will run till this moment, then it goes to the second channel, and I will apply code from here, and I will have the output, and my tool will be left at the lower position. This is cutoff itself, and then I will not have anything else on the back spindle beside the end procedures, and this is the bar change procedure, and this is a special code. I described it on the previous webinar. It is the machine parameters. That's all. So this is all with this part. During the next webinar, I will show you more complex things like advanced operations with more interesting synchronization, I hope so, with like, for example, B-axis will perform operations on the back spindle, deep drilling, so like two channels trying to divide one operation, like mixing axis, and more advanced things about this Swiss type machine. Thank you for your attention. I hope to see you next time.
Okay, Marina, thank you very much. There's only one real question over here. I think this can be a very simple one also. It's is option like M34 part ejection sequence available for all citizen machines, or is it a special code which is needed to be bought or switched on?
You know, I'm not a citizen expert, and
That's what I thought.
I'm not supply citizen machine. So you should ask your reseller and supplier. This is what I meant, but I believe it may be like an option, because as I know, even to call, for example, let me show you just a little remark. I was surprised when I found it, because I had had a code. For example, these tools are called like T50, and on the machine they are, but to call it in a program like T50, you have to pay. So even for these tools, you have to add additional payment. So maybe this ejection cycle have to be paid. I don't know, because
Okay.
it's you have
In
it's a
other
great.
words, you should be in touch really with your
Yes.
machine reseller as well, the vendor for your machines. Okay, Marina, thank you very, very much. This has been recorded, and we will see you hopefully in our next webinar. Take care, everyone, and have a great day. Bye-bye.